So we're starting to get into the meat of it here with this conference. And we have the panel discussion entitled Clutter is a Universal Concern. So by universal, I think we're talking about looking around the entire
mic strength isn't hitting quite as.
Delighted to have some folks here from the UK.
I feel like the mic out isn't coming.
So before we get started, let's do a quick
as much as it
introduction.
was.
So I can ask and let's introduce themselves. Maybe Claire, starting with you there.
Thank you. I'm Clare Allen. I work at Ofcom in the UK as a spectrum engineer. I started my career assigning links and moved on with some stuff to get involved in the ITU and propagation work. And last November, I became responsible for APOA propagation in the ITUR.
I'm Stephane Gagnon, Vice President of Research at the Communications Research Center in Canada. Started my career in the high-tech sector in Ottawa, mostly Bell in research and semiconductor industry, serving the wireless industry. Joined the CRC 9 years ago, and I lead multiple teams doing research all the way from, I have a team that has engineers and technicians that can go out there and do propagation measurements
back here
and setups that they're responsible for labs, sounder equipment, anechoic chambers, and the like. Propagation antenna teams and big data analytics type team that does machine learning on propagation and big data. Thank you.
I think some wonderful panels here to get started. Just a housekeeping note, we're happy to take questions as well during the session. Hey, we've got a microphone. Jeremy's got a microphone there. And I think as well for the folks online, for the attendees online, they can use the chat I think as well if they have any questions. So kind of keeping, of course, on the React, right? And Claire, you were very critical, I think, in the working party 3, which deals with propagation. They just ended a session here that ITS actually hosted. In approximately 2 weeks, you had like 70 people from many different institutions. So I think would you be able to kind of give us a quick summary of how that ended up? What some of the issues were for the session for the past couple of weeks.
That's this guy.
Yeah, so I've been thinking a bit about Clutter and where it all started and how we got involved and started on this work. Is it a long history? So Study Group 3 is responsible for providing advice on propagation modelling to administrations and to the other study groups so that they can undertake their work in WRC and get the allocations so that they can then start assigning services. So it's very important that we're a scientific group. We consider evidence and build consensus, which is part of the conference theme. So we need to ensure that we're offering impartial advice. That's the key thing. So people come to Study Group 3 from all industries. They come from the space sector, the mobile sector, the military, all over, and administrations and sector members and academia as well. We get quite a lot of academic interest. So it's a lot of different people wanting to do their own things with the spectrum, but we're very much a scientific group looking to come up with models that are justifiable. And it's so much more important now as we're moving into a world where we need spectrum for everything and everyone needs all the spectrum. So we have to figure out sharing, and it's important that the models are giving a true picture. I think in the past we used to have models for interference and for planning, and propagation models are just about propagation losses. How much does the energy dissipate in the environment with which you're working? So I think we're trying to move a bit more towards that. Looking back at the history, when I first started at Study Group 3, Clutter was one number. You took your frequency, you applied your equation, and if it was over a gig, it was about 20 dBs. Now, that obviously isn't true. Billy presented evidence yesterday saying that Clutter at 3.5 gigahertz could be anything from -3 to 35 dBs. So there's a lot of variability. And how do we bring this into our models? So we have path-specific models where we take a terrain profile, we take the clutter along it, we do all the calculations for diffraction, for troposphere, ferric scattering even, and all the propagation models. And it used to be that we did all that for the path and added 20 dBs. Obviously, that wasn't going to work forever. In the early 2000s, we developed a point-to-area model, which was also path-specific, and it handled clutter a little bit better. It started adding a height onto the terrain in the diffraction calculation. And then we knew that clutter at the end of the link was important. So we had another loss based on, again, on diffraction. So actually, we went a bit too far in the other way. So in one model, we had 20 dBs, in the other, we had 30 plus, so probably about the right number, but we were also counting it along the profile. So in the past few years, we've done quite a lot of work. The UK did a large set of measurements all over the country. So we're trying to get the different areas of the environment. So from London to Southampton, which is a small town on the coast, well, it's not a small city on the coast in the south of England, up to the Highlands of Scotland. So we have many different areas. And we did a lot of work between 400 megahertz and 6 gigahertz. And with that, we were able to adapt the models based on evidence, so that they now better represent clutter. So the one that was underestimating loss has now come up, and the one that was overestimating loss has come down. So path specific, great, kind of sorted. But when we came to WRC 19 and what we needed for that, and the IMT issue, IMT wanting frequencies in the millimeter wave, it was clear that this 20 dB of clutter loss wasn't going to work. So lots of people came with lots of measurements and ideas for modeling. And that was a very intense year and a half. Study group 3 only gets a year and a half to consider WRC agenda items because we're one of the contributing groups. We don't do the studies ourselves. We just provide the advice. So we only get a small amount of time. And it was a Herculean effort, but we did come up with 2 statistical clutter loss models. The first one was based on measurements, very similar to the work that was done yesterday in the tutorial. And the other one was a slant path model, which was based on when we were moving up into millimeter wave, it was more difficult to do sort of elevated paths measurements for them, especially back in 2015. I think now we're better placed to do those measurements. So we took a statistical modeling approach and then did a little bit of verification with measurements. So we still had a backup that we thought it was in the right ballpark. So that was a great success, used in all the studies. And then moving on now, we're looking to extend that model down in frequency. So for the millimeter waves, we sort of cut off at 10 gigahertz and said it was fine for 10 gigahertz up. But now we're coming down in frequency. So we've got to take other things into consideration. There's more likely to be a ground reflection that will impact the results. So I think in the past 2 weeks, we've had a lot of discussions, some of them a little heated. As I said, there are different sides of the argument coming in on this. But I think the key thing that we got out of the meeting last week was we understand what the issues are on both sides. So one of the key things, obviously, with IMT is the very complicated antenna systems that we're going to be considering. It's not a case of you're just putting a directional antenna on a mast, which is very understandable. So we need to understand how the models are going to be used so that we can make sure that they're fit for purpose. And I think we came to a certain amount of understanding, and hopefully we can all work together in our very short year that we've got to extend these models.
So, coming out of the WRC 23, I keep hearing a statistic that 80% of the agenda items are like satellite focused, right? And you mentioned terrestrial and satellite as being part of this. Was that a large part of the discussion as well, not only on the terrestrial IMT, but also, and to use that word sharing, which I'm delighted you used the word sharing in our national spectrum strategy. That word is used 21 times just to kind of give it a sense of, here in the US, how we're trying to manage the spectrum through the sharing regime. So, but getting back to the point on space, how are the models being considered there for the multitude of those agenda items being contemplated for the next WRC?
Yeah, so there are a lot of space agenda items, and Clutter comes into pretty much all of them because there's some terrestrial component. So as I said, it was based originally on stochastic modeling. We're very much a ray launching sort of situation. We tried to characterize the environment in quite a simple way, which I guess actually brings me on to another point that I meant to make. Another thing that's changed over the last 10 years or so is the availability of data and terrain data. It used to be that, we did our fixed links planning on 50 meters resolution data. Well, we still do. It's quite a good resolution for that. But more and more data is becoming available for systems where you're looking at in the built environment. That's very important. But it's also important to know your data and to make sure you're using the right data. And that's something that we've definitely found comparing our models to measurements, is that if you just make the wrong assumptions with your very high resolution data, you can get completely the wrong answer. But that's taken me away from the satellite modeling. So it's based on array launching simulation. And then at the lower frequencies, we've had an awful lot of input from measurements. And trying to gain consensus is interesting. I think we still need a few more iterations of the modeling and understanding of the measurements. And those are the key things. You need to keep revisiting it, but you really need to understand what the measurements are. And getting those high elevation measurements can be very trying. We've had some really good measurements from all over the world using drones, Billy's done some excellent stuff using high sites in the mountains. But bringing that all together, covering the whole elevation space, it's challenging, but I'm sure we can get there.
When we're talking about the elevation above the horizon, going
Yeah.
up, for example, the
Yeah.
zenith, and that's an interesting idea with using drones as well, and perhaps that could be helpful with the more advanced antenna systems used for IMT, because I think that's a consideration, is how those beams work in a not quite a randomized environment, but certainly there's a statistical perspective on how much, for example, the radiation goes above the horizon.
Yeah.
And by the way, thank you for using, I think we're the first group that used DB in this session. So congratulations, Clare.
I was told not to be afraid of keeping it technical.
Love it. So shifting across the pond here to Canada, Stephane, I think we kind of touched on the use cases that Clare is referring to with regard to satellite, terrestrial. Can you take it a little bit deeper on that?
Yeah, so I'll talk a little bit about the Canadian research that we've been doing and why we've been asked to do this research. When I introduced myself, I'm from the CRC, Communications Research Center. Within Canada, we report into the STS department, which is Spectrum Telecom Sector, where in the US, you would have NTIA and FCC manage all the spectrum for the country. In Canada, we only have STS. They manage both commercial and government-owned spectrum. So they've asked us for help in mid-band and millimeter wave for a program called non-competitive licensing that they launched in the Spectrum Outlook 2023 to 2027. So within Canada, for mid-band and millimeter wave, there's going to be basically free spectrum available for, specific vertical use cases like agriculture, industrial, campuses, healthcare, and the likes. So we had to come up with a mechanism to be able to allocate spectrum quickly, but on a very large number of spectrum licenses, but for small areas. So the view is that people will ask for spectrum for a small geographic location. And in the background, we need a tool, that's where we come in, to go and do a modeling of the environment of this is where they want spectrum,
is it going to interfere with neighbors and satellites in the areas like ground earth station and the like. So for the last 18 to 24 months, we've done a lot of work in clutter modeling, and also the use of that clutter data. Like Claire brought up the data aspect, like we have, like Adrian leads a team of data engineers to consume, thousands and thousands of data measurements, not only measurements that we've done ourselves, but also HRDEM data, like high density data, historic foliage data that sometimes is getting old. So we have to make sure that you're using, like recent data for your analysis. And all of this mixed together creates this automatic engine that's going to be allocating licenses in the future. So our context is a context of government, right? So the context of everybody in this room is also another aspect that we will be discussing this week, right? So our angle is to, of course, allocate as much spectrum as possible for Canadians and SMEs, while at the same time not impeding on existing industries like satellite companies and the likes. So where you come from on the modeling that you're doing will influence what side of the fence you want to sit on, right? So, and that's going to be the interesting debate to get to consensus, I think, at the end of the day, right? So it's like, what's your perspective and what do you bring to the table? Like our teams have to worry about creating a tool that will work across the entire country, where sometimes someone will come to the table with a very specific small use case. So that brings a different perspective to the discussion. So there's, and we have ourselves internal debates on, we're doing measurements, and when we use it, with a P452 or P1811 model, and we introduce the clutter in it, when we go do a measurement and compare the results, it doesn't line up. So then we have to tweak the model. We tweak our clutter model to try to get the answer to line up with the measurement, right? So how we do that and how we automate the whole thing is a source of debate as well, right? So all kinds of different topics that we internally have, and this the ISART is actually super timely for us because we're having these internal debates, and in the last few weeks we've been looking forward to the debate that's going to happen this week to bring back to our discussion, hey, this is like what the industry is feeling about all this. So we're really happy to be here.
So Stephane, you mentioned from the Canadian perspective, kind of there's more mid focus on the mid-band and millimeter wave.
Well, we've spent a lot of time on mid-band, but we also started working on millimeter wave. So we want to do non-competitive licensing, basically opening it up for mid-band, but also in millimeter wave in the future. So in the next year or two, we'll do that at millimeter wave as well. And that will probably serve more like fixed wireless applications. In a lot of industrial applications, they need lots of bandwidth. Industry 4.0 might need lots of high throughput applications. So we're looking at both, in the mid-band to do like private networks, but also in millimeter wave for some specific applications.
So from a frequency assignment perspective, Canada is attempting to develop a model that could be used to determine not only the protected service area, but also the interfering service area to whatever class of station in these private networks, for example.
Yeah.
So is there, from a policy perspective, will these models be shared with the users of these non-competitive authorizations? Is there, or maybe jumping ahead on that one, but just kind of wondering, as we're developing the models, and it seems like, they may have to file assignment applications, how will they know where their areas of opportunity would exist?
The model is like, it's not one clutter model, and we're using for mid-band like 1812, for example. like how we use the model will not be 100% disclosed, but the way the tool works and the assumptions behind how we're trying to avoid, interference and the likes, that will be discussed. Adrian, I don't know if you want to jump in here, but
so the models to be used by the licensing engine will be publicly disclosed to everyone or publicly available. Stakeholders could implement their own models if they need to. But the idea is that this will be implemented in automated systems in the servers of the regulator, and the licensing process will be automated. People go in the portal, apply for their license, and automatically, sometime later, they get a response. Okay. All the AMC compatibility analysis, ensuring that the incumbents are protected, and all that stuff will be covered. So,
thanks, Adrian.
So that will be kind of a service provided by the regulator.
Absolutely.
Okay.
So one of the point that Claire and you asked earlier was, the height of the measurements. But the more and more we go to smaller cells, those towers are lowering, right? So very often the tower height is now below it used to be above the clutter. Now it's right in the clutter, right? So we have more chance to go right through or try to a tree or a building. So how we model the clutter is becoming more and more important as the smaller cells get. That might be less so for millimeter wave, but definitely at mid-band, that can be the case.
Yeah, I think that's an excellent point. Is I think historically you had much taller sites, whether the early cell sites or even going back in the broadcast days for FM and TV, to have your transmitting and receiving antennas right above the clutter. So yeah, it makes it all the more important.
Absolutely. So, and kudos to the organizers, like looking at the lineup of all the different, panels there will be. We're going to dissect the whole thing, and we've done quite a bit of measurements. Adrian's going to lead a panel on measurement and data, and we are also going to be sharing those measurements and data, just like your team is about to do.
Sure.
So there's lots of discussions going on around that, and the more we can share, the better. We've also benefited from a lot of data from the UK in our current analysis, and data sharing and learning from each other is definitely an aspect that we keep working on.
Yeah, I love the collaborative relationship with building up, hopefully, this immense database of all these measurement points that can hopefully yield to models with greater confidence.
So I think sharing data and measurements is great, but sharing the know-how and sharing how we stormed and normed around all those debates, right? So sharing the learnings of what we've considered and then where we landed on. So basically sharing our assumptions and then how we eventually got to a consensus on our use case. But again, depending on the use case, the consensus might be a little bit different, right?
So going back to the measurements, Claire, and I think you mentioned as well that, in the Working Party 3, there are a couple different, if I understood correctly, there are a couple different directions, one going with kind of an empirical based model and one more of a deterministic based model. So how could you characterize how the discussion went on kind of which model would be better for which application or use case?
So the history of that goes way back to sort of 2016.
Right.
And at one stage, I thought I had everyone in the room agreeing that we'd have just one model, because a terrestrial model is just 0 degrees elevation and below. So, but yeah, that didn't happen. Consensus, you can't always get consensus in that short period of time, but we did settle on the sort of the 2 different approaches. And sometimes you just have to get the job done. So that happened. But yeah, I mean, as I said, it was so much more, it's difficult to do measurements in millimeter wave. We were able to combine our terrestrial measurements with existing data sets. So you mentioned a big database. Study Group 3 has one of those. We have a number of campaigns going way back to the 50s and 60s, because it's still all good, although nowadays I guess we have to be a little bit careful that we're using the right data, and it has been difficult to look back in the databases and use them for clutter, because you don't know what the state of the clutter was in those days. We had some UK measurements that were used to develop the ducting model, and I did manage to use some of those in our comparisons with benchmarking 452, because I had an old map and I could pretty much guarantee that the clutter hadn't changed too much since then. And that's the other thing I mentioned earlier, data. So much more data is available. I was able to just Google and find pictures of places from the 1950s, aerial photography, which I could then use to inform whether I was making a good decision or a bad decision on my clutter map. You couldn't do that 20 years ago. It just wasn't there. So I think we're so lucky that we've got so much available to us. But then again, we're also a little bit, stifled by the fact there's just so much data out there,
Right.
which we can make use of. I think I went away from the question, sorry.
Yeah, I'll pause here. Are there any questions in the room as we're continuing on? Okay, not seeing any, and probably no questions online. Just taking a pause here. Okay.
Nope.
So I think that's a great point on the historical data, right? Because I suspect that was more back in the days when the antennas were a higher elevation, but nevertheless, when you were far removed from the tower, you could get more into the clutter environment. So I think the historical, taking a look at the maps, and also, Claire, I think you mentioned earlier that kind of understanding what that data is, right? And not making any, not putting words in your mouth, but any conclusions from that data without understanding the environment. Is that a large data repository going back that far, or is it kind of sparse?
It's a large data set that's been put together over many, many years. But as you say, the key is to understand and know what the input data was. I know that when we were developing 1812, there was a huge effort led by the US in 3K1. And we definitely had, a massive exercise cleaning that up. And that was where we first introduced clutter. So there is data out there for the lower frequencies, but not so much for the higher ones. And that's where we needed more info basically at the moment.
So going back to
when I say higher, I'm talking about above 2 gigs.
Yeah, those are probably few and far between there. What about for the historical data? Do they have like long propagation paths, or are they more confined to short propagation paths, or are they just
it's a mixture, variety? But yeah, we've got long data paths. As I say, a lot of the models developed for the ducting and tropospheric scatter were there, but could definitely do with an update and some more higher frequency info.
Circling back to the use cases, I know your perspective is from the Working Party 3, but I think in the UK as well, I think they're kind of exploring, the mid-band spectrum, however we define that, 3 maybe gigahertz is something, right? Is that are you hearing as well from Ofcom that's an item of a priority as well, or are there other bands?
Oh yeah, I mean, we're definitely looking at hybrid solutions. I think gone are the days where, bands are cleared. You have to live together. You have to consider the different use cases of the different technologies. If one's indoor and one's outdoor, they can probably coexist to a certain extent. If we've got the information to back it up. So that's why things like building entry loss is important, and understanding your housing stock and how that will interfere.
So I'm glad you brought up the indoor versus outdoor propagation. Is that technically considered part of the clutter measurements as the building attenuation losses, or is that a kind of a separate? That's
a separate theme of work for us, but we're also aware that if you're coming in from if you've got a signal coming over the rooftops and down into a building, which may be your interference scenario, there'd be a combination of clutter because it would come through the clutter and then into the building. So that's definitely an area of interest. We've had a few contributions on it, but we haven't had any conclusions. We've had sort of conflicting evidence on that issue, on the combination of the two.
So
I can throw in at the CRC many years ago, we did a lot of work around millimeter wave and building indoor versus outdoor, and how much of the energy can actually make it through the walls or windows, and and the different types of windows, like the windows that reflect the sun, not necessarily they let the sun pass through, but not the heat, right? So those thermal glass, like they act pretty much like a brick wall, compared to old style windows. So we did a lot of measurements. I'm not sure if we've shared any of those with the team through Pierre, but and we have this debate internally, like indoor versus outdoor, and millimeter wave could basically be like two separate environment for sure. But when you come down in frequency, then you kind of have to do more work, right? So especially if you start looking at upper mid band, 7 to 8 gig, discussions, mid band and the 6 gigahertz. So at those frequencies, then it's less cut and dry than it is at millimeter wave. So.
Yeah, and I think that's going to be very interesting, which I think UK has taken the lead on as well, and seeing if there's a coexistence possibility between INT and essentially unlicensed Wi-Fi. I think take into account maybe that boundary situation that occurs in indoor-outdoor.
Yeah.
I know that's another part of Ofcom, Clare, but
I
think it's got a lot of interest worldwide on that.
I think we're also trying to balance the fact that mobile operators don't just have that single frequency band. So they can always offload, and that helps the sharing scenario as well.
Yeah. Circling back to the Working Party 3, right? You mentioned it's going to be a very short year. Sounds like a lot of work to be done, and to me that means a lot of work to be done and not a lot of time. So what are and you also mentioned that the Working Party 3 is kind of more of kind of a consulting to the other working parties. Can you describe what some of the kind of the near term priorities would be in terms of the deadlines for Working Party 3? In other words, what's kind of at the top of the list? That's kind of we have to kind of finish this by the end of the year.
So I think we've spent the last 4 years debating this, I suppose is a polite way of saying it, and we're coming to an understanding of the sort of model that we have and how we might be able to adapt it. So I think an understanding of how it's used is key for us. So we need some information from the other study groups back. We get that partially by people attending our meetings. So study group 3 only meets once a year. So there'll be a lot of talk in the correspondence group. We have a monthly meeting usually. But getting measurement results and marrying it up with the modeling and hopefully convincing everyone is the key priority, I think, is really getting everyone on the same page with how this model is coming together, and understanding the theory behind it. And we're trying to model the whole environment. So this is something I wanted to mention earlier. The terms rural, urban, and suburban are widely used.
Sure.
What's urban to me is not urban to you. What's rural to you is not rural to me. Yeah. So I think we need to try and move away from this sort of very subjective description into something a bit more quantitative. And I think that's something Canada's been doing with their clutter mapping. Right. It's a real, using the data along with measurements to set what the categorization should be. And that would make me very happy if we just stopped using those terms, I have to say.
Or have more rigid definition for those terms, or what would be the alternative?
That would be great. I don't think that would be very helpful in the ITU because we have to consider the whole globe. I think you could possibly do it in a country where you've got a certain degree of similarity.
Mm.
I don't know, I might be wrong, but
Sure.
you know, if you compare Africa to Europe to America to Asia, they're just so different.
Yeah, the tree foliage and the height of buildings and what is urban, what's suburban and rural in Canada versus Mexico is very, very different, right? So, and even in our country, when we go north, the further north you go, the lower the trees are because there's less sun and the lakes, and then they disappear completely. So basically, like Claire was mentioning, we analyze the whole country, you know, in the clouds, you know, and then with all of our data, and then we map, you know, on these ITU models to their definition of what's urban, suburban, and then we analyze each clutter and classify it for the entire Canada, which is a lot of work at a certain precision, like 30-meter precision. We've considered 10-meter precision, but then the models would take too long to run. So there's also that aspect of what precision you do all your work at based on the size of your country. Like the US is similar to Canada in size. So the more precision you're after, the longer your model might take. But again, if your use case is not to analyze the whole country, then you're working with a small problem, perhaps you can be a little bit more precise.
So on those classifications, is it kind of like a pixel based, you know, like there's a determination based upon this geographic footprint of some dimension that it fits into one of those use categories?
Well, you look at your satellite picture and then you're seeing, you know, foliage or buildings and the likes. And if you marry it with your other data, which probably has like elevations and all these things, then you can classify whether it's a house, an industry, or building of some sort, a tree, and the elevation of it and the like. So then you classify it for your clutter map, if you wish, right? So you basically have to decipher all of that for the whole area you're analyzing as a step in your pipeline to come to the answer of the use case you're modeling effectively.
And is that done in automatic format?
Yes,
okay.
That's all automated, of course. Yeah, and it combines multiple data sets from multiple provenance that has multiple ages and the likes. So, yeah,
it's pretty sophisticated.
Yeah. So one other thing I wanted to come back, Claire mentioned something about that triggered to me what Jeremy brought up in his opening remark about machine learning. So we like CRC contributed the machine learning propagation in the group last week or the week before, and transfer learning. So with the machine learning work that we've done, like we're trying to take data. Let's say an example. I don't think that's the example we use, but let's say you have data in Chicago and you do the modeling and you get propagation measurement. Then we try to replicate the thing with our machine learning tool, and then try to go to New York and see if that works, right? So we're trying to see if the transfer learning actually works from city to city, so you don't need data everywhere, right? So if or when we incorporate more machine learning in what we're doing, when we can actually go out and take measurement in one area, if we're comfortable that the transfer learning actually works in our machine learning environment, then more of us can benefit from those measurements. So that machine learning and AI in the future will accelerate, I think, and give us more the precision that we were talking about earlier. Like Jeremy used some words like accurate modeling propagation. Right now it's maybe utopic, right? Because so many things at the end of the day in how you use the clutter that you've developed in your model can deviate from the right answer or the accurate answer that we would all love to get to. There's so many little things that can throw off your measurement, like the age of your data and the likes. So we make all kinds of assumptions. I think we have to document those assumptions so that when we explain our model, people can appreciate that it's not black and white, right? It's really gray, and how we decided to cut and dice our work was justified and based on ground truth where possible, and where we had to make assumption, we document them. And
So you used a term I hadn't heard before, transfer learning.
yeah,
right? I think
that's a machine learning.
So that's, I think in the context of this, I think you were suggesting take city A, but that may be very similar to city B. Is that what it's used in?
Yeah, basically if you can do like a machine learning model, and that's quote unquote your ground truth. So you can test your model against something that's well known, and then once your model works with the verified data, then you can see if it makes sense when you transfer it to a different environment. Obviously, you need the same amount of or similar amounts of data in those other environments to train your model and the likes. And but yeah, that's kind of a high level explanation of transfer learning.
Bringing it back on the international, right? Clutter is a universal, international concern. Can you describe, Clare, how in Working Party 3 in particular, how the administration support that? In other words, do kind of all three regions have sufficient administrations to provide input into this, or can you characterize how the interest is around globally on this, on the propagation?
So the ITU is contribution driven. So we don't get a set amount from each region, or it's very much the person who wants to do the work does it and can push it through. Although it obviously works better if we get contributions from everywhere, and that's where the building entry loss model was very successful. It had contributions from all over the world. So it was much more diverse. The clutter modeling has been quite heavily based in Europe, I would say, originally. And then in the last period, it was more sort of Asia. Japan took a very big interest in it. But then we also had contributions from Billy, who possibly showed that they were maybe angling towards a high-rise environment and making it perfect for the high-rise. But as I say, urban in one place isn't the same as urban in another. And if you're going to be making international decisions on it, you don't want it to be biased towards one particular environment.
Right.
So it was very valuable to have that data coming out of the US to say, well, hey, wait a minute. Actually, the advice that we were giving, that the current model should be all right, was okay. And that also gave us comfort in the advice that we'd given them in the meantime to sort of use the model extended down to lower frequencies. It wouldn't be vastly broken, which was great. The studies on an international basis are quite generic. So we put a lot of effort into coming up with these sophisticated models for path profiles, using the terrain and the clutter. And then they don't actually use them for the WRC studies. That side of things is very much the assignments that administrations do, the local licensing, that kind of thing. When it comes to the ITU studies, they're looking for simpler models, which I think is why clutter gets such a big spotlight. They can use a very basic free space loss for short distances and just add the clutter on, and it's really appealing because it's got the variability in it, and it's got a very simple model to apply. No more than 5 equations. So that's another thing we have to balance up in the international world is, complexity. They won't use it, versus simplicity, they may abuse it. And I think that's another topic that's going to be discussed later on, the abuse of models.
So I think that's an interesting point. So if I got it, so from an allocation perspective, it tends to be the administrations prefer to use kind of a more simplistic model. And you mentioned like free space and putting a clutter on top of that in many instances where you don't have a very, very large range. But maybe at the local administration level, when they're working on the actual frequency assignments for their country, their administration, they would use a more sophisticated type model.
Yeah, definitely.
Is that generally the case?
Yeah.
Okay.
Yes, and then there's sort of like coordination between countries. You'll use quite a simple model to see whether you need coordination, and then you'll go into the details of it to make sure that the interference risk actually is much lower.
Okay.
I think that's a standard practice that we've been using for a long time.
Okay, we actually have some questions.
Excellent.
You want to go to our first question? Okay.
Yeah.
For questions in the room, please state your name and affiliation.
Hi, my name is Tony Rainier, and I have lots of affiliations, mostly DoD-oriented, Clutter type stuff. But so, Claire, you mentioned, and I think it was come up in a couple of different contexts, that the deployment models are changing, right? So we used to, in the old days, it was all big towers way above the clutter. Who cared about clutter? Everybody was above the clutter. Now we see more and more deployment models changing. And then the question about Bell, building entry loss came in, and of course we have 2109, which is, I don't know how long it's been around, but forever. But it seems to me that as our deployment models going forward change, and we have more and more indoor, both downlink and uplink users, that it's more important to really sort of explore this. And so I guess for each of you, in terms of either the ITU or the countries in which you're thinking about this, are you looking to do more work and incorporating more measurements and more model building in the Bell models to sort of supplement the clutter work? Thank you.
Yeah, so I guess I come back to our contribution driven. So definitely on the work plan is to look at the combination of Clutter and Bell, which I think is very important. Extending the Bell model, we're interested in site specific, because at the moment it's very much, there are two classes of building, thermally efficient and traditional, but that's sort of the only separation. And again, a thermally efficient building in Dubai is different to a thermally efficient building in Denver. So yeah, we're looking to get more information. If people are interested in it, we'll develop it. If they're not, it'll probably sit in the work plan for a long time.
That's an interesting observation, though, the Dubai versus here in Denver and the thermal buildings, because I would suspect that they're maybe designed to maybe some standard, but that may be a national standard. So with the thermal window planes, for example, there's a big delta between the two. Oh, okay, interesting.
Yeah.
Many DBs.
Many DBs.
Just wanted to
Put
throw
DBs
DB in there.
Yeah.
Thanks. Quick question, Andy Clegg from Google. Is there an effort in standardizing the interchange format for clutter data for RF propagation purposes? Like, I can think, the description geometrically of clutter, the electromagnetic properties of clutter, whether a building has energy efficient windows or not. I mean, there's a lot of data here. Is there an effort to create a standard interchange format for those kind of data?
I'm not aware of one.
No, I mean, there's been a clutter mapping standardization agent work going on within the UN, but it doesn't cover radio wave propagation. Unfortunately, we heard about it just towards the end of the project, so we weren't able to get a sort of in on that. But no, that's one of the problems. I mean, I talked to my national mapping agency, the Ordnance Survey, and I say, well, I don't care if it's a hospital or a shopping mall or whatever. I want to know, how tall it is, how big it is, what it's made of. And that, that conversation took me about 5 years to get through to them. It really doesn't matter what it's used for. But for other people that they're supporting, it's very important. So I think we're getting more information. They're understanding more about this. So getting more impetus to get that information, but definitely not on an international scale, I wouldn't just say.
So I think every time we get data, and not just clutter data, but data in general, even if we buy the same type of data, when it comes in, we have this data cleaning exercise that needs to happen to kind of line up all the similar type of data that we have to the same column headings, if you wish, right? So we need to clean it up, reorganize it, resave it in the format that we want, and sometimes generate the data that's missing based on when you compare two data sets. So the data cleaning aspect of consuming data is time consuming, sometimes can take 80% of the time. It's kind of a boring task, but it needs to get done. Like in this case, there's definitely value in talking about it. Again, would you ever get to a real consensus? I'm not sure. I think it would depend on what you actually measured and what data was available in that scenario of measurement, right? So it would be pretty much impossible to think of every permutation ahead of time and creating a standard, but some chat about it would definitely be good.
Okay, we do have a couple questions online. So the first one is from Mark Norton, engineer at DoD-CIO. Can you discuss the impact of 5G ISAC, integrated sensing and communications, on clutter modeling? New requirements or any new use cases, etc.?
Could you repeat the question one more
Yeah.
time, Jeremy?
Can you discuss the impact of 5G ISAC, integrated sensing and communications, ISAC, on clutter modeling? New requirements, question mark, new use cases, question mark.
I'm afraid I'm a propagation person, not a technology person.
Yeah.
I don't really have an answer, but would anyone in the audience have an answer for this? Or
we have a taker.
Hey, yeah, so Dan Massey, OUSDRE, actually a semi-colleague of Mark as well. I'm over in the OUSDRE office. He's over in CIO. I think what Mark is alluding to is from a DoD perspective and from a network perspective in general, there's a lot of opportunity not just to use the network as for propagation, but to understand what kind of new sensing and what kind of signals that we might be able to infer from network usage. Can we use that to sort of better adapt to growing spectrum sharing, spectrum interference? Can we identify opportunities to maybe better understand the environment we're operating in? And I think that's what Mark is alluding to by the integrated sensing and comms. Yeah. From our bias perspective, in our program as Future G, one of our 4 areas of emphasis is what we're calling ISAC, or integrated sensing and comms. So that's I think that's an interesting challenge as to what can not just thinking about this as, hey, am I able to use this spectrum without interference? Am I able to talk up? But what can this tell me about the environment and how can I adapt? And I would say from our standpoint, as we get more into spectrum sharing, spectrum interference, that'll become more and more crucial. So I hope that
I can comment on that a little bit. So that's a great point. I think the challenge is the companies, the wireless service providers, they'll have gear from Ericsson, Nokia, Samsung, and other companies that I shouldn't mention here, and those pieces of equipment gather a lot of data on the health and the quality of service of their network on the wireless side and the whole application side. And they keep that information close to their vest, right? So from a government perspective, we do talk to those companies and share with them, like, if you were to share that kind of sensing information with us, it would definitely help us understand the spectrum framework and usage and what QoS people are experiencing out there. And that would augment our clutter modeling and understanding, if you wish, because they have the ground truth, right? And they have a very detailed ground truth and at any moment, any wireless service provider should be able to tell you that if they installed a small cell in the middle of the intersection of, 2 big streets, pick your city, they would maximize their service offering for their customers. The middle of the intersection, of course, can't be deployed, but they have a lot of data. So I think they own so much sensing data that we can't benefit from. So from a policy perspective, do we start asking in our policy for some of that data to be shared, right? And if that was the case, what would that look like? And how would that benefit perhaps government organizations to service industry and D&D and DoD here in the US better, right? So we talk about it. The policy doesn't necessarily ask for that kind of data yet, but sometimes behind closed door in an NDA, they do share that kind of data with us. And we thrive, we love it because it kind of helps us understand our research better, right? And so on. But that, I think as we evolve and as we provide spectrum in the future, maybe there's going to be some hooks in there so that sharing happens.
Yeah, that could be a very, very large resource that I don't think a lot of administrations have tapped yet.
No.
And especially kind of getting that feedback loop on how the link is closed could be very interesting. And also I think to the point of handling the inter-service interference as well, which we know occurs on the wireless side. Yep. Jeremy,
we've got time for one more.
Last question. Yeah.
Perfect.
Thank you. Adrian Flores, ERC Canada. So this is a great question. Last question on the integrated sensing and communications from 5G network. So characterizing clutter is very, very difficult. A lot of measurement data will be needed. So more scalable ways to capture that data would be great. We're going to have a panel tomorrow on measurements and data. So I think that's a great topic for that panel as well to continue this discussion. Just some early comments on that. That would be really great if we can use existing networks to capture the propagation measurements. There are some challenges with normalizing those measurements by the existing networks because they are done in the context of the 5G protocols or LTE protocols, and then normalizing that to other use cases is not always straightforward. But from that perspective, once that challenge is solved, I think this is a valuable way to collect more data to use it for modeling. Thank you.
Yep. Thank you for the observations and look forward to that next panel. So I think that concludes this panel session. I'd certainly like to appreciate having the international perspective from Clare and Stephane coming from these great distances. Clare, I think you were here, for already almost 2 weeks. So I assume you'll be getting a Colorado driver's license soon. You'll be, but really appreciate. Give a round of appreciation for our panelists today.
Thanks for having us.
Great. So thank you.